Write the differential equations governing the mechanical rotational system as shown in figure. Draw torque voltage and torque current electrical analogous circuits. Let us assume that the applied torque is T. The displacement at this end is theta 1. The displacement of J2 is theta 2. Displacement of J3 is theta 3. Displacement of J1 is theta 1. So now we have to obtain the mathematical model of this mechanical system. J1, the torque is applied torque is T, therefore reaction forces will rotate the system in the opposite direction. That's why that is the torque is T J1. The another torque that rotates in the opposite direction is Tk and Tb1, Tk1, Tb1 are the three forces acting on it. The displacement of this because of the applied torque T is theta 1. Therefore, the mathematical model is J1. The differential equation governing the mechanical system is J1 d square theta 1 by dt square plus b1 d by dt of one end is connected to J1, other end is connected to J2. Both ends has different displacement. Therefore, d by dt of theta 1 minus theta 2 plus k1 theta 1 minus theta 2. That is equal to the applied torque T. This is the first equation. Second equation is for J2. For J2, no applied torque. Its displacement is theta 2 and clockwise. Therefore, the reaction forces are in the opposite direction. T J2, T K1, T B1, T B2. These are the reaction forces acting in it. Therefore, J2 d square theta 2 by dt square plus P1 d by dt of theta 2 minus theta 1 plus K1 theta 2 minus theta 1 plus B2 d by dt of theta 2 minus theta 3 equal to 0. That is second equation. Third equation is for the third inertia J3. The displacement is theta 3. Therefore, the reaction forces are in the opposite direction. T J3, T K3, T B2. These are the reaction forces. Three reaction forces. No applied force, applied torque. Therefore, we have to write J3 J3 t square theta 3 by dt square plus B2 d by dt of theta 3 minus theta 2 plus K3 theta. One end is fixed here for K3. That's why only theta 3 equal to 0. This is third equation. The first part of the question is over. Write the differential equations governing the mechanical rotational systems as shown in figure. That's all. So these are the three differential equations governing the mechanical system. Now we have to obtain torque voltage analogy. Torque voltage analogy means we have to replace torque by applied voltage V of t and J by L, P by R, K by 1 by C, and the displacement theta by Q. Therefore, if you replace the first equation, what you are getting is J1 becomes L1 d square q1 by dt square plus d becomes r1 d1 becomes r1 d by dt of q1 minus q2 plus a1 k1 is replaced by 1 by 1 by c1 integral of q1 minus 1 by c1 q1 minus q2 equal to applied torque T of t, that becomes V of t. That becomes V of t. This is the fourth equation. The second equation becomes J2 becomes L2 d square q2 by dt square plus R1 d by dt of q2 minus q1 plus 1 by c1 q2 minus q1 plus b2, that is r2 d by dt of q2 minus q3 equal to 0. This is fifth equation. Then third equation implies L3 d square q3 by dt square plus that d2 becomes r2 d by dt of q3 minus q2 plus 1 by c3 q3 equal to 0. This becomes sixth equation. dq by dt equal to I, that we know. Therefore, if you apply and therefore q equal to integral of I dt. If you replace these two, 7 and 8, if you substitute 7 and 8 in 4, we will get 4 becomes L1 di1 by dt plus R1 I1 minus I2, because dq is I, plus 1 by C1 integral of I1 minus I2 dt equal to V of t. This is ninth equation. Fifth equation implies L2 di2 by dt plus R I2 minus I1 plus R1 1 by C1 I2 minus I1 plus R2 I2 minus I3 equal to 0. This is 10th equation. Sixth equation, similarly, if you substitute dq by dt equal to I in the sixth equation, it becomes L3 di by dt plus R2 I3 minus I2 plus 1 by C3 integral of 1 by C3 integral of I3 dt equal to 0. This is 11th equation. So 9, 10, 11 is electrical analogous of mechanical system. This three equations is the electrical torque voltage analogy. For that, we can draw the circuit, electrical analogous circuit for this mechanical system. What is the use of getting an analogous system? Because constructing a mechanical system is very difficult. Constructing a mechanical system is difficult. But if you want to know the characteristics of that mechanical system, we can find one analogous electrical system. If we find the characteristics of that electrical system that can be easily constructed, we can understand the behavior of mechanical system. That is the advantage of analogous system. So that is the reason why we are finding analogous electrical system. Electrical system can be easily constructed. So L1, DI, I1, I2, and I3. Three currents are there. Therefore, three loops are there. So three loops are there. I1, I2, I3 are the three loops. This is first loop, second loop, first loop, current through this is I1, second loop, current through this is I2, this is third loop, current through this is I3. So L1 through L1, I1 alone is flowing, therefore we can mention here L1. R1, both currents I1 and I2, I1 minus I2, therefore R1 can be mentioned here. C1, both currents are flowing through that, that's why C1, both currents are flowing, I1 and I2. V of t is applied voltage is V of t. So this is V of t. Applied voltage V of t. That's all about 9th equation. 10th equation, L2, through L2 only I2 is flowing, therefore we can put here. If you put here only I2 will flow. R1, both I2 and I1 and I2 are flowing, already mentioned. C1 already mentioned. That's all about the second loop. Third loop, L3 is there. L3 is there. R2 common to R2 is here. It's here. R2 is common to second loop and third loop. Therefore, we have to mention here. This is R2. R2 is common to second loop and third loop. C3 is common only in third loop. C1 is common to both. That's all. B2 means what? R2. That's all. That's all about the analogous system. So how easy to construct this electrical system? A voltage source, three inductors, one capacitor, and two resistances. If you connect like this, two capacitors, two resistances, and three inductors, if you connect like that, it becomes analogous to mechanical system. That's why it's very simple. Second part of that question is over. Third part we have to find. For third part, we have to replace the mechanical first equation. Should be replaced J by C, B by 1 by R, K by 1 by L, torque, applied torque by I of T, and this displacement theta by phi flux. Therefore, first equation becomes J should be replaced by C. Therefore, C1 d square phi 1 by dt square plus B should be replaced by 1 by R1 d by dt of theta 1, that is phi 1 minus phi 2 plus phi1 minus phi2 k. That is k should be replaced by 1 by L1 phi1 minus phi2 equal to T. T becomes I of T for torque current analogy. Torque current analogy. Applied torque is T, displacement theta 1, theta 2, theta 3. This is 13th equation. Then 14th, second equation becomes C2 d square phi 2 by dt square plus 1 by R1 d by dt of phi 2 minus phi 1 plus 1 by L1 phi 2 minus phi 1. 1 by L1 phi 2 minus phi 1. And one more, this B2 is there, that is plus 1 by R2 d by dt of phi 2 minus phi 3 equal to 0. This is 14th equation. Next, the third equation becomes C3 d square phi 3 by dt square plus 1 by R2 d by dt of phi 3 minus phi 2 plus k becomes 1 by L3 phi 3 because one end is fixed equal to 0. That is 15th equation. Now we know that d phi by dt equal to v and phi equal to integral of v dt. This is 13, 14, 15. This becomes 16. This becomes 17. Therefore, 13 becomes equation number 13. If we implement 16, the equation 16, 17 is substituted in 13. The 13 becomes C1 dv1 by dt plus 1 by R1 v1 minus v2 plus 1 by L1 integral of v1 minus v2 dt equal to I of t. This becomes 18th equation. Then 14th equation becomes C2 dv2 by dt plus 1 by R1 v2 minus v1 plus 1 by L1 integral of v2 minus v1 dt plus 1 by second equation. 14th equation, 1 by R2 v2 minus v3 equal to 0. This becomes the 19th equation. And the 15 becomes, equation 15 becomes C3 d phi 3 by dt. Phi 3 becomes v3 dv3 by dt plus 1 by R2 v3 minus v2 plus 1 by L3 integral of v3 dt. This becomes equal to 0. This becomes 20th equation. 18, 19, and 20 is the torque current electrical analogous of mechanical system. So here node voltages are there. How many node voltages are? 3 node voltages are there. V1, V2, and V3. But in nodal analysis, one reference always will be there, V reference. So 4 voltages. So in the first equation, the 18th equation consists of C1 dV1. C1 is across V1 only. So this is reference voltage, the baseline. So V1, we can draw C1. V1 to reference C1. Then R1 is between V1 and V2. R1 is between V1 and V2. And L1 is between V1 and V2. L1 is between V1 and V2. Then I of t is applied voltage, applied current across V1. Therefore, it should be current source applied across V of t. E of t is applied across V1. Then that's all about nodal equation 18. 19, if you consider C2 and C2 is between V2 and reference. R1 is between V2 and V1 already drawn. L1 is between V1 and V2 already drawn. R2 is between V2 and V3. R2 is between V2 and V3. That's all about 19th equation. If you consider 20th equation, C3 is between V3 and reference. And R2 is between V2 and V3. L3 is between V3 and ground. L3 is L3. That's all. That's all. So we can draw the circuit like this. Stop here. That's all. This is the current analogy of a mechanical system, rotational mechanical system. That's all.